In this section, let's take a look at provisioning additional swap storage as necessary on your system in the event that you run low and have to on the fly make swap available so that your applications continue to run, albeit in a degraded fashion because of the lack of in-memory access. However, nonetheless, your applications will continue to run. So let's gedit. And that's our FS tab, so we'll bring up, that's the most recent invocation, our Unix CBT notes, and close the FS tab for now, although we'll update it later on if sysinstall fails to do so. So from time to time on a running production system, you'll notice that as your user processes increase, you will run short on memory as well as storage and other resources, processing power, etc. But one area of interest that's perhaps the most troubling and crippling to a system is the lack of RAM. RAM is where data are stored and supplied to the CPU at the fastest rate possible on any computer system. As a consequence, it's critical that you have sufficient RAM. So swap storage allocation becomes something that the administrator engineer needs to know and be able to implement on the fly. So it features the ability to provide virtual RAM on the fly. And there are a number of methods supported. So 3 options are supported by BSD. They include in no particular order, but of course in an order of preference, a dedicated partition, so a dedicated swap partition, which we were forced to configure during installation, and can provision on the fly if there's additional storage. A swap file that's provisioned on an existing UFS or UFS version 2 file system, so swap file on existing partition. And optionally, least preferred is a swap file across or over NFS. So least preferred because of the network implications, most preferred because it is a dedicated partition. And somewhere in between, if you must, you can provision a file. Why is a swap partition preferred? Because it's dedicated, it's arranged, it isn't shared with standard user data. So there isn't the opportunity for the same level of fragmentation and slow I/O as a consequence. But it isn't always possible to provision extra swap partitions on the fly. It is suggested, however, when you provision systems, that you secure storage that is not a part of the general usage block. So, in other words, hide or siphon off some storage, perhaps a couple gigs, just in the event that you need extra RAM to keep your applications going. So, let's look at 2 of these options. First, we'll begin with the dedicated swap option. So, tasks, provision, swap via dedicated partition. Now, if you recall, we've migrated /user to the new user2 block. So user now occupies that partition. So the old user, which is 6-point-something gigabytes, is available. So we can repurpose that particular partition for swap storage. So what does it entail? Well, first you should know some of the tools that are available to you to determine what the current swap layout is. Swap info will enumerate the current swap situation. And we're logged in as root, so we don't have to SU in to run these utilities. So let's Control-Shift-T. Let's do a which swap info. And it's an SBIN utility. Swap info enumerates the current allocation. So what we see here currently is that the first or second disk, in this case DA1, so the second SATA disk, first slice, partition B, is our partition that's dedicated to swap, of which 48 megs is currently used. So this is our swap partition that's available, and that's about 2%. It represents 2%. Now if you also run top, you'll see a dump of the swap partition. So this is the swap space that's available, of which 2% is currently in use. So either swap on or top, swap info or top, that is. Swap on is used to turn on swapping. Swap info or top will return the current swap storage that's available. Now, of course, this is represented by 512 blocks, so you'd have to divide by the number of blocks to get the total amount of swap available, which is about a gig. Now, certainly at 2%, we don't need a new partition, but hypothetically, if we did need a new partition, we should have the tools necessary. So swap info enumerates. So enumerates current swap allocation, including percent usage or capacity. So now that we have hypothetically hit a limit with respect to existing swap, how do we provision new swap space? We can use sysinstall to repurpose the former partition. df-h shows us the various partitions. If you recall, the former user partition was a 6-point-something gig partition, which currently is unmounted. So that is the partition that we're going to use. In fact, if we cat etc fstab, we'll probably see a trace of the old partition. That's da0 s1d. So this is the partition that's of interest to us. Let's copy this. And we're going to manage this particular partition, da0 s1d, which can be enabled as swap, but it has to be repurposed because it's currently a normal UFS file system partition. Now, since this partition is already a UFS partition, as opposed to repartitioning it as swap, as we would if the partition were new, we'll mount it and create a file in it, so it's a quasi, or becomes a quasi-dedicated partition. Another way to implement a dedicated partition is to actually add a partition to the system and dedicate it all together using sysinstall. So for this partition, we're going to remount it somewhere else, perhaps as swap temp or swap 1 or something to that effect, and then create a file within it. So let's just note, because this is an existing UFS FS file system, we'll simply create a swap file within it, which is akin to, of course, having a dedicated partition. So it's very close. And then we'll use sysinstall after we've provisioned dedicated storage. So perhaps we'll provision 2 gigs and then use sysinstall to create a swap partition within that 2 gigabyte space. So how do we create a file within this /user? Well, it needs to be repurposed as we've mentioned. So we're going to modify etc fstab. So C vi etc or gedit, since we're logged into a root shell. So gedit etc fstab modify to remount /user as, let's say, swap 1, for example, or swap 0. Either or. We'll go with swap 1, and then we'll create a file as swap 0. So let's go to our list and open the fstab file. So here is the D partition that we've mentioned. If we uncomment it, and we can also place it in the section that is perhaps below the existing /user and have it mounted after. It's not important, but we can, just to show that it is something that we did as part of the classroom. And let's just note, used for swap file. So we're treating it as a dedicated partition. So this is only one way to implement swap. So da0 s1d is currently a user partition, which has data on it, by the way. We can remove everything on it because we now have a clean user setup. This we'd like to mount at, let's say, swap 1, a directory we need to create. So it'll be UFS, but it can contain within it a swap file. So let's save the changes to fstab. This will be swap 1, and we will have to remove everything. So remove data from, just to avoid confusion, /swap 1 post mount. We could also just overlay a new file system, either swap or UFS, using the standard tools. That's yet another way to do it, to dedicate the partition. A number of methods exist. So let's see what's happening here. We'll do a mount -a. This will, well, first we need to make the directory /swap 1 and then mount -a. This will remount the various items. Now let's see what it's saying. da0 s1d, which is our partition, is currently busy. Let's df-h to see if it shows up anywhere on the list. s1 s1d da0 s1d is mounted at /media /disk. So let's take a look at media /disk. That's actually mounted. So let's umount it. Now it's U-mounted. Now let's mount A and df-h. So it was mounted. Let's see, this reads that it has only 49 megabytes. And by the way, correction on the swap. Let's do a swap info again. It's actually not 48 megs. This is the block count. So it's really half of this, which is about 24 megs. So this is representing 512 blocks, 512 byte blocks. So this is really divided by 224 megs, and top should show that. And it shows 24 megs used. So again, let's df-h, and there is swap 1. And insofar as etcfs tab is concerned, when this machine reboots, it'll mount /swap1. Now, swap1 doesn't currently have enough space to store our swap file. So we'll need to navigate to swap1, and we can do a number of things. We can just do a remove rf*, which is a dangerous command, but because this is already mirrored elsewhere, we'll just execute it and have it remove as many items as it possibly can from the directory. There's some flagged items that will not remove easily without other commands, immutable items and so on, for the sake of preserving /user, but nonetheless we should be able to free up enough space to create the swap file within it. Now while that removes the items that are there, let's go through the other steps that are required to provision this particular swap file. So provision swap file via dedicated UFS partition. So this is akin to option B, and then we'll do option B next. So while we're cleaning up things, how do we provision this particular file? Well, we use the command dd that we just recently used to create files, test files, 10 meg files, etc. We use also the input facility of dev0, which will allow us to write the file with an appropriate format. We change the byte size, and then we set the count to something that's sensible to create the appropriate file. Now we need to know how much swap storage we'd like. So let's start with something simple such as 512 megs. Ideally you should have twice random access memory represented in swap. Currently swap info tells us that we have a gig, which is twice, let's do our top to see how much memory we have, twice the random access memory. So that's clear. So let's go ahead and just add another 512. So we'll use the dd command with an input facility of dev0. This properly formats the file for swap usage. We'll set an output file of /swap1, and we'll simply call it swap0. We'll set a byte size instead of 1024 bytes, 1024K bytes, and then a count of 512. This will get us 512 million bytes, or 512 megabytes. Now, before we execute this command, we need to ensure that the space is available on /swap1. So let's do a df-h, and swap1 now has 5.3 gigabytes available. So the remove is actually working. Some items cannot be removed because of other flags that are associated, but it is cleaning things up, and if we take a look now, we should see it's much cleaner. So with that said, we can use dd to create the file in /swap1. Now this will create the file as 512 megabytes momentarily, and then we will finish the configuration. Just takes a little while to write the file, also while it's making other changes to the system, removing the items that are there. There's one other command that we have to run that will actually set the file accordingly. Actually, two other commands, mdconfig and swap on. So now we have this swap1 file, or swap0 file, in the swap1 mount point, which is 512 megabytes, filled with dev0 data. We then need to run mdconfig. This is the memory device utility, which sets up an in-memory storage device. So this creates the link between memory and the disk to allow the kernel to swap between memory and the disk. And we'll use these options, t vnode. There's an option swap if you check the help, but we're setting it up as a vnode, which will create a devmd device, which then gets mounted as swap. And it's going to be created against the file swap1 swap0. You could also name your files based on the amount of storage in the file. So this will set up the device, an in-memory device that the kernel can use. mdconfig. If you do a man on mdconfig, you'll see. You do a file against swap 0. It's just simply a data file. Now that we've set the device that will be available, our next step is to swap on this new device, which is located in the dev tree as simply devmd0. So swap on, which enables swapping on a device on devmd0. This actually enables the swap. So enables swap on the device devmd0, which is a pointer to swap1 swap0 file because of the md config that we just ran. So swap on devmd0. Again, that devmd0 device is located in the dev tree. This is the device that was just created, which is really a pointer to our swap1 swap0 file. Now we have this additional swapping enabled. We can confirm it, of course, using tools such as top, which will show the additional swap that's available. We've just added an additional 512 megs. And we may also execute swap info. Swap info now shows 2 devices that are available for swap usage. Dev DA1S1B, which is the original swap, 2 million bytes, 2 million blocks, that is, for 1 million or 1 megabyte. 1 million bytes or 1 gigabyte, that is. And devmd0, which is just about a million blocks or 512 megabytes. So this gives us a total of 3 million blocks or 1.5 gigabytes worth of swap storage, of which only 2% is in use. But we also need to ensure that when the system reboots, it'll reinstate this particular swap file. So we'll need to update etcrc.conf when you're referencing a swap file. And in it, we'll place swap file equals and the location to the swap file, which is swap1 swap0. This is important, otherwise the swap device does not become available upon system reinvocation. So ensures initialization upon reboot. So let's modify that file, including this item. We also need to ensure that the file is set to 600. Let's just double check it. That's important as well. Change mod 600 swap 0. And let's gedit etcrc.conf to ensure that this item comes back up. And we'll just include in the list here. Swap file equals the following. Save the changes. So when the system reboots, this swap will come back. We'll also test it to ensure that it does come up and also provision the additional storage so that we can show you how to provision dedicated partition for swap. So I use top and swap info to reveal available swap, current swap. That raises a question. Supposing you needed to currently or temporarily disable this additional swap. There's a swap off command. So swap info reveals the current swap partitions and or files. devmd0 is just a pointer, a dev tree entry created by mdconfig. But what if you wanted to turn off swapping, for example? Well, swap off allows you to turn off swapping if you specify, for example, devmd0 and then a rerun of swap info, you will see that it has turned it off on that particular item. To turn it back on, you simply rerun the swap on command. So swap on and then swap info. So you can turn off with swap off. The same is the case in Linux. So use swap off, in this case devmd0, to temporarily disable swapping on file or device. We've turned it into a device with mdconfig. That's essentially what we've done. Whereas in Linux, we can simply just point to the file and cross-reference it, and the kernel finds it with no trouble whatsoever. So now we're set up for additional swap storage. So again, let's just recap the steps. If you have an existing UFS partition First, ensure that there's enough space on the partition. So df-h, and in particular df-h /swap1. So because of the remove RF, we've freed up about 6 gigs, a little over 6 gigs. Once you know there's enough space, and we alluded to sysinstall initially because we were going to repurpose the partition, but we'll do that shortly with a new partition. Once you know there's enough space, let's just remove this step and relabel them so it's not confusing. So these will be changed accordingly, and in the next step we'll use sysinstall. And again, you can always reference the command line utilities such as BSD label to make these changes from the command line. So again, once you know there's enough space, you can check your current swap configuration using swap info. You can check top to see how much percentage or what percentage is in use. You then want to mount the available file system somewhere else. So we did so as /swap1. Clean up the data, make sure that, or clean up the storage so that there's enough space for your file. Use the infamous dd command to generate a file using deb0 as a source and make it as big as you need it to be. So 512 megs, 1 gig, 2 gigs, etc. Use mdconfig with the vnode option to turn the particular file into a device. Once it's been turned into a device, swap on the device. We should also include that you should change mod to 600 so that others aren't able to access the contents of, so let's intersperse this somewhere, of the file. So change mod 0600 the device, which is /swap1 swap 0. That's important as well. Ensures that non-privileged users do not have access to swap file contents. It's not mandatory, but it's helpful from a security perspective. And then once you've turned on swapping, you can confirm that the swapping's configured with swap info as well as top. Modify etcrc.conf and place an entry for the swap file to be initiated when the system comes up. This applies to any file that you define. So if we define an extra file, which we will momentarily, we'll repeat the process, that will be the case. Now let's see how we do this all again from scratch. So we have swap1. Now supposing we wanted to store, for the sake of distributing swap performance across storage to somewhere else. For example, var has 814 megs free, user has 12 gigs free. So supposing we'd like to use 512 megs of either of these since they have space available. Let's go with user because var is susceptible to considerable log changes. So we're going to now actually use user. So to provision swap file on active /user. So what are the steps? Well, we already know our swap layout. Swap info tells us that, but it never hurts to just run it. Swap info to ascertain current configuration. Once we know that, our next step is to write a file. dd input file equals dev0. Output file will this time be equal to /user. And let's call this file swap2. And the byte size will set to 1024K. And the count, we can set this equal to 1024, which will give us a 1 gigabyte file. So this will write the file into /user. And in fact, if you'd like, you can even name it something that's distinct, such as swap1g, which tells us that it's swap 1 gigabyte or swap 1 GB. Either or. That tells us a little bit about what the file is, but of course an LSL will tell us directly what the file is. Now once this is in place, you can optionally change mod at this stage. Change mod 0600 /user /swap1g. That takes care of that step. Secures the file. Now once that's in place, we need mdconfig to create the device for us. So mdconfig vnode user swap1g. This will write the file accordingly as a device entry, and it automatically increments device entries for us. Once that's in place, we swap on. And this will become devmd1 because devmd0 already exists. LSL dev md, md0 is the only item. So let's go through those steps. Swap info. So currently we have 3 million blocks, 1.5 gigabytes. dd input file equals dev0. The output file will be equal to /user swap 1g. The byte size will be 1024 kilobytes with a count of 1024. So this will give us 1,000 Ks, or 1,000 1024 Ks, or 1024 times 1024 Ks for a full gigabyte. So let's create the file. This will write it to /user momentarily. In fact, you can watch the file being created, but in this case it created it rather quickly, 5 seconds. So an LSLH of user swap 1g shows that the file is a gig. Now it exists. Now we said we'd like to secure the file, so let's change mod 600 or 0600. If you omit the leading 0, it's assumed to be a 0. So 600 means 0600. A leading 0 is assumed by the operating system. So change mod 600, swap 1g, followed by an LSLH user swap 1g just to confirm. So now it's secured at 600. Now we need to create or generate the device, the dev tree device, using mdconfig. So mdconfig, and again you can just do a man mdconfig to see how the options apply. Type vnode, it's a virtual node, against user swap 1g. This one should be 1. That's where the number comes from. We just copied and pasted. So now in dev we should see 2 MD devices, MD0 and MD1. MD1 represents the 1 gigabyte file. Let's just update our notes to reflect that we had the 0 in there, which is a carryover from the other one. So that should be 1. So provisions dev MD1 device. And then now we're going to turn on the swapping with swap on. But again, swap info will reveal it's not yet enabled. We're still at 3 million blocks. Swap on dev md1. Swap info now shows we're at 5,145,728. So divide this by 2, and that gets you about 2.5 gigabytes worth of swap. Of course, we're currently not using much of it, 25 megs. And of course, to be sure that this file is provisioned when the system comes up, simply update etcrc.conf. So etcrc.conf needs to be updated to reflect the new entry, which will be swap file equals /user swap 1g. And let's just copy this block to save ourselves from having to type it. And we'll open from our list rc.conf. Since we're logged in as root, it just makes things easier. So there are 2 files. We can even include a comment. 512 MB swap file. And this is a 1 GB swap file. And they can be enabled or disabled by simply commenting each of those items. So now our swap's in place from a file perspective. Now we can actually reboot the system. Now what we'll do is provision storage. So we'll shut down with an init 0, add more storage, 2 gigs of storage, and then finish by provisioning swap on a dedicated partition. So now our system's coming back up, and momentarily we'll see the additional storage. As we've recalled, when you boot your system, just use dmessage. Or, optionally, take a look at var run dmessage.boot to see towards the end of the file what storage has been detected, if any. If you look quickly enough, you'll see the DA values on the screen in bright white before the handoff to init, but it flashes by quickly on fast systems. And there's DA3. Now let's take a look. This says there is an error in rcconf. So let's go to etc. We probably missed something. And let's take a look. Swap file equals. We're missing a quote for the first one. So good that we've caught it here. So we're actually in single user mode. So that's vi rc.conf. Let's do a df-h. Mount all got us in. Now let's add the quote. The copy and paste clobbered this. I in VI will insert and allow you to navigate to where you need to go. And escape shift:/WQ will do the trick. So let's reboot. And again, if we look quickly enough in the bright white towards the end, which is equivalent to what you see when you use dmessage or look at the dmessage.boot file, you'll see the device DA3, which is the additional 2 gigs that is, of storage, of which we'll use perhaps a gig for swap. So now we're back to the GUI. Let's log in as root yet again, just to simplify our changes. Certainly not promoting root as a standard means of using the system. However, it can be quite useful for administrative tasks. It saves us time. So we've corrected that. Let's do a history grep gedit. We really want the option 232 to become the most recent. So this is where we've left off. Let's just be sure that our quote from the earlier item in our notes is correct. And that should be rc.conf. This is where we're missing that terminating quote. That's why it copied over incorrectly. So now, next step, 3, provision dedicated swap partition. And this is the actual preferred method, but it's not always possible because you may not have storage. So this is where we use sysinstall. And we'll modify, in this case, disk DA3 to create, first of all, a slice, a full slice for the disk, and then a partition for swap. Sysinstall will automatically handle things for us, but we'll always confirm in the background to be sure that it did its job. So sysinstall. This is going to be post configuration, configure. And we have yet to lay out a slice on DA3, so let's go ahead and fdisk it. DA3, we can use the entire disk with option A and then write the changes. It doesn't require boot manager. So now that's been written. Now let's quit. And for safety, we'll just cancel and quit altogether and then rerun sysinstall, this time to label the disk. This may not always be required, but we've found that many times it is. So DA3. Now we need to create a partition. So what type of partition do we need? Well, we want a swap partition. Do we want it to be the entire 4 million plus blocks, or perhaps a gigabyte, which is roughly half of the number of blocks that are here? Well, if you have a calculator handy, you can get even closer to the actual size that you need. So we know that we're dealing with 512K blocks, and supposing we want 1 gig, let's say 1024 megabytes. So you could do 1024 times 1024. That gets you a full megabyte. Now we need 1024 of these. In fact, 1,000 of those. 1024 times 1024 times 1,000 of those, and there's our number. Now divide this by 512, and there we have a closer value to what we want. So 2048000, and it'll be of type swap. This will give us an extra gig. So there's our gig of space that we want. Now let's write the changes with W. And then this will write the changes to the disk. Now let's exit. We'll confirm with swap info. So now we're up to 6,145,152 bytes, which is roughly 3 gigs. And more importantly, we see DA3S1B that is available. We also see dev md0. Let's just double check our etcrc.conf, and we should have swap file / user swap 1G. Let's just double check user swap 1G. Chances are the MD1 device wasn't committed, so let's LSL dev MD, tab it out, and that's the issue. MD0 was saved, MD1 was not saved. So let's go ahead and just re-provision that. Hopefully it sticks this time. It could be because of the error that we made. So MD config vnode option against user swap 1G. We currently don't need all of this storage, but it still should be there. And let's LSL dev md star. Now MD1's in place. Let's swap on dev md1 and then swap info. And now we have the extra blocks. So now it's in place. Hopefully it saves. Otherwise we'll have to debug. But now we have the dedicated partition DA3S1B dedicated to swap as well. So now we have a full 8 million plus bytes for, or blocks that is, 512 byte blocks for swap, which gives us roughly 4 gigs of swap available. And top will borne that out. Swap total 4 gigabytes roughly, of which nothing's currently being used. So in a nutshell, we've covered setting up swap. You can do it on a partition basis, file basis. Now that we have a partition in place, you can actually disable the files by modifying rc.conf and turn them on when you need. So for example, let's just include that as another step. So let's just note fdisk and then label, then confirm with swap info and top. And let's just add as an additional task, disable fs-based swap files until needed by modifying etcrc.conf, which should be in our history. So let's pull it up from file, and we'll just disable both of these items. They're not necessary. And since we would rather not reboot the system at this stage, let's just swap off these items. So swap off dev md, let's try to use brackets here, 0, 1, and let's do a swap info again. And now swapping is enabled only on the partitions, the original setup during installation and the newly provisioned, which gives us 4 million blocks about, which is about 2 gigabytes. So that means top should reveal the total divided by 2 gigabytes. It's always divided by 2 because it's 512 byte blocks. So 2 gigabytes of swap, which is more than sufficient for our configuration. So that's how you provision swap. Few options, introduces a number of hooks, but nonetheless, it's rather straightforward, just a handful of steps.